This lesson is on lines, and the first thing that we need to remember is about slope. Slope is considered the rise over the run if we're looking at a line. And the formula for slope is y minus y over x minus x. And books and teachers will sometimes put y2 minus y1 and x2 minus x1. But that's just to show you that the y and the x here have to be from the same point, and the y and the x here have to be from the same point. And it doesn't matter which point you use first, so I just put y minus y over x minus x. If you have a positive slope, that line is going uphill left to right. If your slope is negative, that line is going downhill from left to right. If you get an undefined slope, that happens when you get a 0 on the bottom of your fraction. That is a vertical line. And while we're there, let's make note that if you get a vertical line, the equation of that vertical line is x equals a number, whatever that number is. That is a special case. And then if you get a slope of 0, that would have come from having an equation where you got 0 on top of a number. That would be a horizontal line, and the equation for a horizontal line is y equals some number. And the reason these two special cases are the way that they are is because if you think about it, if you plotted a bunch of points that were in a vertical line, all of the x values would be the same. If you plotted a bunch of points that were in a horizontal line, all of the y values would be the same. And so those equations are really easy, but people tend to forget them. Those are your special cases. Okay, the first form of a line that we're going to be talking about today is slope-intercept form, and this is the one that you're probably most familiar with, y equals mx plus b, because you use that a lot in Algebra 1 or Math 1. In this case, m is your slope, and b is your y-intercept. And you can easily graph a line using that form. Most of you have been trained to do that. So if we look at our first example, we want to put this into slope-intercept form and sketch it. This is not already in slope-intercept form because the x and the y are on the same side. In slope-intercept form, the y is by itself. So I need to subtract x from both sides, and I have negative x plus 2. And when I look at that, that tells me I have a slope of negative 1. This is an understood 1, so this is a negative 1 in front of the x. And I have y-intercept of 2. So if I go to sketch that, I'm going to start with my y-intercept of 2. And I'm going to put a point right there. And then my slope is negative 1. Since it's negative, I'm going to go down from that y-intercept, but I always go right. Positive means I go up, negative means I go down, but I always go right. So down 1, right 1 puts me at 1, 1. And then I just sketch my line through that. Our next two examples are our special cases. And so if you'll remember, when y equals 2, that is a horizontal line, and all of the y values on that line should be at 2. So if I go to y values of 2, I can think about points here. All these points have y value of 2, so that kind of tells me where my horizontal line is going to be. And so there is my graph. The second special case, number 3, they want us to sketch x equals 3. So think about where x equals 3 and any points that would have an x value of 3. And if you think about all the points that would have an x value of 3, that would make this vertical line. And so those are my two special cases. Okay, and I'm going to do one more example that's not a special case. So if I want to sketch this, I first need to get it in y equals mx plus b. So I'm going to add the 4x and subtract the 5. Okay, so that's going to leave me with a negative y on this side. And then I have 4x minus 5 on this side. And then I need to divide by negative 1. So that's going to give me a positive y, a negative 4x, and a positive 5. Okay, as was just pointed out, yes, you could have actually just started the whole thing by adding y, but I tend to like my variable y on the left and my variable x on the right. That's just habit, but yes, either way is fine. When I get to this point, again, I want to make note, my slope is negative 4. My y-intercept is 5. So since I have a y-intercept of 5, I'm going to go up to 5 and put a point. Then since my slope is negative 4, the negative tells me I'm going down, but I always go right. So I'm going to go down 1, 2, 3, 4, and right 1. And then I'm going to connect those in a line as best I can. Don't seem to be very good at it, but you get the point. You've done this before, so hopefully this is just review. Okay, now we're going to move on to a different form of a line, and this is point slope form, and I use this a lot. And so I put a star here because this may be something that you're not as familiar with, but you will be and you need to be. We will use it a lot in this class. We will use it a lot in calculus. With point slope form, you're going to always keep this y and this x, but the ones that have 1s with them will come from a point, and the m is representing the slope. This form is best if you're trying to get an equation. The other form is best if you're trying to graph. This one is best if you're trying to get an equation. So our example here is we're trying to find the equation of a line with the given point and slope. They gave us a point, they gave us a slope. So I write my point slope form, but I leave out those places that have the 1s and the m. So you just need to remember to set this up by saying y minus on one side, x minus on the other, and the x minus is in a parentheses. Then you want to fill in. If you're looking at your point, the x value of your point will go with the x in the equation. So if the 1 is here, I'm going to stick it here with the x. Since my y value in the point is negative 2, I'm going to put it with the y. So x goes with x, y goes with y. The slope always goes in front of the parentheses. So I filled in those parts. And then I can simplify, and 2 negatives make a positive, so I have y plus 2. And over here I can distribute and get 3x minus 3. And then if I subtract 2, I'll be in slope-intercept form if I need to be. So 3x minus 5. This line and this line are the same thing. They are the same graph. They're just two different forms. Okay? So if you needed to graph this line, this would be a good one to use. But since we're just coming up with the equation, we used this to plug in. Alright, let's do number 6. So again, I'm going to start by writing y minus and x minus with my spaces. I'm going to plug my y value with my y and my x value with my x. I'm going to put my slope in the front. Then on the left, I don't have anything to simplify, so I just have y minus 7. On the right, I have 2 negatives, so I want to think of that as positive. And I want to distribute, so I get 2x plus 6. And then finally, I can add my 7. And y equals 2x plus 13. Okay, let's do a couple more examples that have a little bit more to them. We can also use that same idea even if they give us 2 points. The only thing is we have to do a little bit of work beforehand, and that work is finding the slope. So we have to use the slope formula I was talking about at the very beginning, using y minus y over x minus x. So I'm going to use y minus y over x minus x. And again, make sure you come from one point to the other the same direction both times. And so that's going to give me 1/5. So everybody remember slope. Alright, then we come over and we write our point slope form. Y minus on one side, x minus on the other. And we're going to fill in. I know my slope is 1/5, and my slope always goes in front of the parentheses. And then you can actually use either point. Either point should get you the same equation in the end. So if I have a point that has a 0, I'm going to use it because that's going to be easier to simplify. So x with x, I'm going to put the -2 in. Y with y, put my 0 in. And then simplify. So y minus 0 is just y. I have two negatives over here that'll make a positive, and then I'll distribute. So 1/5 times x, I'm just going to write 1/5 x, and 1/5 times 2 is 2/5. And so there's my equation. Two more. So number 8, again, if I'm going to write the equation, I have to start by finding the slope. So I need to do y minus y over x minus x. And so on top I get plus positive, so that'll make it 3. And then on the bottom, 2 minus 2 is 0. That immediately tells me this is going to be a special case. 0 on the bottom means that the slope is undefined. Undefined slope means it's a vertical line, and if you look, both points have the same x value. My equation is just x equals 2. I don't have to go through all those other steps. I just jump to the fact that it's a special case and I know what the equation is. For our last example, this might be a time that you want to pause and try this one on your own. Okay, so the first thing that you hopefully did was find your slope by saying y minus y over x minus x. And I get a -5 on top of a 1, which just means my slope is -5. And then if I plug in to my point slope form, I can use either point. But like I said, if there's a 0, I'm going to use it. So I have a 0 with this one for the x, so I'm going to plug that with my x. And the 4 is the y value. I'll put it with the y. And the slope goes in front. And so then I'm just going to simplify. So on this side, the left side, I just have y minus 4. On the right side, x minus 0 is just x, so I really just have -5x. And then I add 4. So I have -5x plus 4. And hopefully that's what you got. This concludes this lesson.